Welcome to A-Level Chemistry. Today we are going to go through the May-June 2021 paper 13, which is the third variant of the multiple choice paper for this year. And while we go through this paper, the questions, I'll give you some tricks that you can use during the exams to get a good score. Now, before we delve into the questions, a gentle reminder that always read all the questions properly. Read them carefully so that you don't miss out any important details, because when I used to practice for my exams, I made the mistake of reading the questions too quickly and I always missed out something important and I ended up making silly mistakes. So to avoid that, read all the questions properly. So the first question, compound X is an organic compound that contains 30.6% carbon, 3.8% hydrogen, 20.4% oxygen and 45.2% chlorine by mass. What is the empirical formula of X? So I realize I've already circled option A, but we'll go through how I got to that answer. So we'll first make a table. And before we delve into any calculations, we need to make sure that all these percentages add up to 100. Because sometimes what they do is they'll leave out hydrogen and they'll give you the percentages of all other compounds in the all other elements in the compound apart from hydrogen. And that's why the percentage won't add up to 100 in all cases. So they expect you to calculate, they expect you to add up all the percentages that are given to make sure that is 100. And if it is not 100, then there's likely something missing out. And in most cases, in fact all cases, the missing element is hydrogen. So you know from that how much percentage of hydrogen is there. Here they've given you everything, so you don't need to worry. But a good practice is to add everything to make sure it adds up to 100. So we need to calculate the empirical formula, and therefore we'll assume that we have 100 grams of the element to make the compound to make the calculations easier. So we calculate the number of moles for each one of them. So for carbon it is 30.6 over 12, which is equal to 2.55. Hydrogen it is 3.8 over 1, which is equal to 3.8. And oxygen it is 20.4 over 16, which is equal to 1.275. And for chlorine it is 45.2 over 35.5, which is equal to 1.273, approximately equal to 1.275. So now we have the number of moles, and using these we calculate the molar ratios. So we use the lowest number of moles for that and divide everything else by that. So this gives us 1, 1, 3 and 2 approximately. And therefore C2H3OCl is the empirical formula, and that's what option A is. Question 2. A sample of propane C3H8 with a mass of 9.61 grams is completely combusted in an excess of oxygen under room conditions. Which volume of carbon dioxide is produced? So, classic stoichiometry question, just write the complete formula, the balanced equation. This is the balanced equation, and then calculate the number of moles of propane, which is 9.61 over 12 into 3 plus 8, which is 0.218 moles. And then we know from the balanced equation that propane is to carbon dioxide is 1:3. So the number of moles of CO2 is 0.218 times 3, which is equal to 0.655. And we know that that every mole of gas under room conditions occupies 24 dm cube volume. So we multiply 0.655 by 24 dm cube and we get 15.7 dm cube. And that's the answer, option D. Question 3. Which atom has the same number of electrons as an ammonium ion? So ammonium ions, NH4+. So we have a nitrogen which has 7 electrons. We have 4 hydrogens, which means 4 more electrons. And then we have a positive charge, which means -1 electron. And that's a total of 10 electrons. So we need to see which among these 4 options has 10 electrons. So magnesium, let's write out the electronic configuration: 1s2, 2s2, 2p6, 3s2. If you look at the periodic table, magnesium is 12, so you will know how to write the electronic configuration for that. This is 12 electrons, so magnesium is not the answer. Sodium, 1s2, 2s2, 2p6, 3s2, 3s1, and that's 11 electrons. Again, sodium is not the answer. Neon, 1s2, 2s2, 2p6, 10 electrons. Yep, likely to be the answer. And then oxygen, 1s2, 2s2, 2p4, which is 8 electrons. Again, this is not the answer. So the answer is option C. Question 4. Ethanol reacts with hydroxylamine NH2OH to form the molecule shown. What is the order of increasing bond angles? Underline these parts so that you don't give them in any other order in the structure from smallest to largest. So X is 109.5 degrees because tetrahedral sp3. Y will be 120 degrees because it is planar sp2. The carbon is sp2 here. The carbon in this one was sp3. And then Z, because it's oxygen, and you know oxygen has a bent structure when it forms single bonds, 104.5 degrees, and therefore the order will be Z, X, Y, and that is option A. Question 5. Descriptions of the bonding in 3 substances are given. Substance 1, strong covalent bonds between atoms, permanent dipole-dipole attractions between molecules. So let's stop right here. Before reading substance 2 and 3, let's see from the table given which option satisfies substance 1. So strong covalent bonds between atoms, permanent dipole-dipole attractions between molecules. So option A is feasible because yes, there are strong covalent bonds and the molecule is polar, so there will be permanent dipole-dipole attractions. Al2Cl6, again, covalent bonds, permanent dipole-dipole attractions because polar, because aluminium and chlorine have different electronegativities. CH2Cl2, again, it's a polar compound as well, and because of the differing electronegativities and because it's not symmetrical and it has strong covalent bonds. CH4, it does have strong covalent bonds, but because carbon and hydrogen have similar electronegativities, it is non-polar, and therefore there are no permanent dipole-dipole attractions. So option D we have already ruled out. Option D cannot be the answer. Then we come back to substance 2 now. Strong covalent bonds between atoms, weak forces between molecules. So Al2Cl6, we just said that there are strong forces between the molecules, so this cannot be the answer. So A is gone now. CH2Cl2, again we said permanent dipole-dipole attractions between between the molecules, so again this cannot be the answer. CH4, weak forces because temporary dipole, induced dipole, which is probably the weakest type of force. So yes, C is a likely answer. CH3OH, again permanent dipole-dipole, so not weak, and therefore we've ruled it out. In fact, CH3OH will also have hydrogen bonds, which means that this can definitely not be the answer. And the last option is substance 3. Now, we've already ruled out A, B, and D, so we know that C should be the answer, but we'll read option for substance 3 because we need to make sure what we are doing is right. So strong covalent bonds between atoms, hydrogen bonding between molecules, CH3OH, definitely hydrogen bonding. So this is the correct answer. Question 6. Which type of bonding is never found in elements? Covalent, yes, found in oxygen, hydrogen. So this cannot be the answer because it says never found in elements. Then ionic, no, it's not found in elements. It's only found in salts and ionic compounds, so therefore definitely they cannot be found in elements. Metallic, all the metals. Van der Waals forces, again argon, the noble gases, all the diatomic gases, we'll find these van der Waals forces. So the answer is B, which is ionic compounds, never found in elements. Using the information in the table, what is the enthalpy change Q for the reaction described? So Cs plus gas plus Br negative gas gives Cs Br solid, and delta H is equal to Q kilojoules per mole. And they've given you this table where they've given you the enthalpies of solution and hydration. Now, whenever you see enthalpy of solution and enthalpy of hydration, you immediately come back to the Hess law for these type of reactions. So let's write that down. Let's write the Hess cycle for this reaction. Cs plus gas plus Br negative gas gives CsBr solid, and Q is the enthalpy change. And then when we dissolve these ions, what we get is the enthalpy change of hydration. Remember, dissolving ions in their gaseous state to give aqueous ions is enthalpy change of hydration, which gives us Cs plus aqueous plus Br negative aqueous, right? And that's minus 276 minus 335, basically summing the enthalpies of hydration. And then when we dissolve CsBr solid to give the aqueous ions, then that's enthalpy change of solution, which is this one. So that's plus 25.9 kilojoule per mole. And now we can use this cycle to calculate Q. And we know that from going from the gaseous ions to the aqueous ions, we can either go directly or we can go to the solid first and then go to the aqueous ions. So either like this or directly like this. So we know that using this relationship, we know that minus 276 minus 335 is equal to Q plus 25.9, and therefore Q turns out to be minus 636.9 kilojoule per mole, which is option A. Next question, question 8. Which enthalpy change is indicated by X in the enthalpy cycle shown? So they've given us a Hess cycle here. We don't have to draw one, thankfully. And let's go through the options. So minus 4 into the enthalpy of combustion of hydrogen. So remember, enthalpy of combustion of hydrogen will be burning 1 mole of hydrogen gas to give the combustion products, and therefore it cannot be minus 4. It should only be it should only be twice the enthalpy of combustion, because why do we need a negative sign here if the enthalpy of combustion itself is negative, right? So we don't need a negative sign here. We only need twice, plus 2 times the enthalpy of combustion, which is not the option, so we cross it out. Plus 4 into the enthalpy, again it should be plus 2. Minus 2 into the enthalpy change of formation of water. Yes, it is twice the enthalpy of formation of water because we have 2 moles of water forming, and but the problem is that it cannot be minus, because if the enthalpy change is exothermic, it will take the minus sign itself. So we don't have to include the minus sign here, and therefore this cannot be the answer. So option D, which I've already circled, is the obvious answer. Copper dissolves in dilute nitric acid, producing a blue solution of copper nitrate, water, and nitrogen oxide as the only products. How many moles of acid react with 3 moles of copper in the balanced equation? So they've given us, they've asked us to react 3 moles of copper. So we'll have to balance the rest of the equation. So let's draw out this equation first, without the balancing, and then we'll balance it. So this is what we get. Now we have 3 coppers on the left, so we need to have 3 coppers on the right, and by having 3 coppers on the right, we have about 3 times 2 times n, because it's NO3 whole twice. So 3 into 2 into n, which is 6 times n. So we have 6n here, and we also have 3 times 2 times 3 oxygens, because it's O3 twice, so 6, and then 3 times from this one, so 6 into 3, 18, and we have 18 oxygens here. But remember, we have a nitrogen and oxygen here, and we have oxygens here as well. So let's put some number, for example 8 here, because that's the last option we get, option D. So 8HNO3, which means we have 8 nitrogens on the left, and we have 6 nitrogens in copper nitrate, which means we need to have 2 in nitrous oxide, And then we have a total of 24 oxygens on the left, and we have 18 oxygens in copper nitrate. So, and 2 oxygens in nitrous oxide. So 18 plus 2, 20, which means we need a 4 here to balance it. And as for the hydrogens, I think it's balanced because 8 hydrogens on the left, 8 hydrogens on the right, balanced. So the answer is option D, 8. Question 10. Nitrogen reacts with hydrogen to produce ammonia. N2 plus 3H2 gives 2NH3. A mixture of 2.00 mole of nitrogen, 6.00 mole of hydrogen, and 2.40 mole of ammonia is allowed to reach equilibrium in a sealed vessel of volume 1 dm cube. It is found that 2.3 mole of nitrogen were present in the equilibrium mixture. Which expression will give the value of Kc? So, in order to calculate Kc, we need to get this data in a more organized way, because they've given us all these numbers and we need to organize them in a table to make our life easier so that we can understand what exactly is happening here. So we have N2, we have H2, and we have NH3. These are the species present in the reaction mixture. And then initially, we have a mixture of 2.00 moles of nitrogen, 6.00 mole of hydrogen, and 2.40 mole of ammonia. And then this reaction mixture is allowed to come to equilibrium in a sealed vessel, and it is found that 2.32 mole of nitrogen were present in the equilibrium mixture. So final, we have 2.32 here, and this means that that 0.32 moles of nitrogen has been created by the time we reach equilibrium. And because nitrogen and ammonia have a 1:2 ratio, that means to create 0.32 moles of hydrogen, 0.64 moles of ammonia had reacted, which means we have 1.76 left. And because of the 1:3 ratio of nitrogen to hydrogen, we know that if 0.32 moles of nitrogen were created, then 0.32 times 3, which is 0.96 moles of hydrogen, were also created. So that's 6.96 total hydrogen in the reaction mixture. So this is final at equilibrium, and because the volume is only 1 dm cube, when we calculate the concentrations, we are dividing all moles by 1, which essentially means we can use the moles instead of the concentrations in the Kc equation. So Kc will be equal to NH3 whole squared over H2 cubed into, which is equal to 1.76 squared over 2.32 for nitrogen and 6.96 cubed for hydrogen, and therefore option A is the correct answer. Question 11. Nitric acid is produced by oxidizing ammonia. The first step is to react ammonia with oxygen in the presence of a catalyst to form nitrogen monoxide. Which set of conditions will produce the greatest yield of nitrogen monoxide at equilibrium? So we need to choose temperature and pressure conditions. So let's just look at the equation and figure out for ourselves what will produce the greatest yield of nitrogen. So it's an exothermic reaction so to produce more nitrogen monoxide, we'll need to lower the temperature, because remember Le Chatelier's principle that that increasing the temperature shifts the reaction equilibrium towards the endothermic side. So we need to go towards the exothermic side, which means we need to reduce the temperature. So we need a low temperature, which means it can only be one of options C and D. And then the total number of moles of gas on the left is 9, and the total number of moles of gas on the right is 10, which means that we are increasing the number of moles, and we need to decrease the pressure, because remember again Le Chatelier's principle, an increase in pressure favors the side of reaction with less number of moles. So we need to lower the pressure to favor the side with more number of moles. So the answer is option D. Question 12. The height of the peak of the curve in a Boltzmann distribution represents the number of molecules that have the most probable energy. A sample of gas has its temperature decreased without changing the number of molecules present. Which statement correctly describes a feature of the Boltzmann distribution for the gas when the temperature decreases? So before we look at the options, let's draw this out, the Boltzmann distribution curves, so that we can see what is happening. So at high temperature, we have something like this. And remember that when temperature decreases, the peak shifts towards the left and the height of the curve increases. So we get something like this. So this is high T and this is low T. And which statement correctly describes a feature of the Boltzmann distribution for the gas when the temperature decreases? The value of the most probable energy would stay the same. No, because as we've seen on our curves, it has decreased. Option B, the number of molecules with the most probable energy would increase. Yes, that's correct, because the peak of the curve has increased. So this option B might be viable. And the area under the molecular energy distribution curve would decrease. No, it stays the same because the total number of molecules is the same. And the number of molecules at the very high energy end of the distribution would stay the same. No, as you can see on the graph, that's not true because it's different. The number of molecules at the very high energy spectrum is different. So the answer is option B. Question 13. Ammonia exists as simple covalent molecules, NH3. Ammonia can react with suitable reagents to form products containing ammonium ions. Ammonia can also react with suitable reagents to form products containing amide ions, NH2 negative. Which of these nitrogen containing species are present in an aqueous solution of ammonia? So let's write an equation of what happens when we add ammonia to water. So remember, ammonia is more basic than water. Ammonia has a pH of 10, water has pH 7. So ammonia is more basic, and remember the Bronsted-Lowry theory of acids and bases. Acids are proton donors, bases are proton acceptors. So the ammonia will accept a proton to make NH4 plus ions, and the H2O, the water, will lose a proton to make hydroxide ions. So which of these nitrogen containing species are present in an aqueous solution of ammonia? Remember, this is an equilibrium, so there's no 100% conversion, and we can see that we have ammonia and ammonium ions in this mixture, and that's option B. So question 14. Which problem can result if too much NH4NO3 is applied to crops by farmers? So option A, not all NH4NO3 is used by plants, and the excess makes the soil alkaline. This is not correct because remember, NH4NO3 will react with alkalis, because remember, ammonium compounds react with bases to form ammonia, a salt, and water. So what will happen is, instead the soil will become more acidic because they are removing the alkalis from the soil. The ammonium compounds will react with the alkalis in the soil. And then option B, rain washes some of the NH4NO3 into rivers where it forms a precipitate. No, ammonium nitrate does not form a precipitate when it washes into rivers. It dissolves. It's very soluble. So this is also not correct. Some of the ammonium nitrate dissolves in groundwater, which may eventually be used for drinking. This is the problem, because you don't want to be consuming that polluted water. So option D is ammonia is produced. This lowers the pH of the soil. Ammonia is produced, but it will raise the pH of the soil because ammonia is alkaline, not acidic. So this is also wrong. So we are sure that option C is the correct answer. Question 15. When descending group 17 from chlorine to iodine, which statement is correct? The hydrides become less thermally stable as they become weaker reducing agents. This is actually wrong because they become weaker oxidizing agents. The hydrides become less thermally stable. HCl, HBr, HI, they will become less thermally stable because these are weaker oxidizing agents, not weaker reducing agents. So this is wrong. And then the hydrides become more thermally stable as the reactivity of the elements decreases. So the thermal stability has not got anything to do with reactivity, and therefore this is wrong. And option C, the volatility of the elements decreases as the van der Waals forces increases. Yes, because as you're going down, the size of the molecule and the number of electrons in the molecule are increasing from chlorine to iodine, and therefore what will happen is that the van der Waals forces will become stronger, and because the van der Waals forces become stronger, the elements evaporate less because their boiling point increases, and hence the volatility of the elements decreases. Because remember, the more the volatile the substance is, the more easily it evaporates, but the stronger the forces, the less easily it will evaporate. So the volatility will be lower. So option C is correct. Option D, the volatility of the elements increases as the size of the molecules increases. This is wrong because of what we discussed in option C. Question 16. A powder is known to be either a single sodium halide or a mixture of two sodium halides. A sample of the powder was dissolved in water. Aqueous silver nitrate was added and a pale yellow precipitate was formed. When concentrated aqueous ammonia was added, this precipitate partly dissolved, leaving a darker yellow precipitate. What could the powder be? Sodium bromide only? No, because remember, sodium bromide will give a cream precipitate and not a yellow precipitate. Sodium iodide only? No, because remember, some of the sodium iodide, silver iodide, which is the yellow precipitate, it is insoluble even in concentrated aqueous ammonia. But the question says that some of the precipitate dissolves, which means that there is something else apart from sodium iodide. A mixture of sodium chloride and sodium bromide? No, because none of these will give a yellow precipitate. And a mixture of sodium chloride and sodium iodide? This is correct because the sodium iodide will give the yellow color and the sodium chloride will give a white color, which is why initially you see a pale yellow precipitate. When you add the concentrated aqueous ammonia, the sodium chloride will dissolve, whereas the sodium iodide will not dissolve, leaving a darker yellow precipitate, which is just the sodium iodide. Which statement is correct? Question 17. Doctors can use the very insoluble magnesium sulfate to investigate the digestive system. Magnesium sulfate is soluble because as you go down group 2, the solubility of the sulfates decreases, which means magnesium sulfate, which is still on top of group 2, will still dissolve. Option B, farmers can lower the pH of the soil by spreading CaCO3 on it. This is wrong because calcium carbonate will react with acids in the soil, and that means the acid content of the soil is decreasing, and therefore the pH will increase, because remember, acids lower the pH. So if the acid content is decreasing, the pH will increase. And then option C, students can test a solution of sulfate ions by using barium nitrate followed by nitric acid. This is correct because this is given in your qualitative analysis booklet, which you should learn for this paper. And option D, the insoluble hydroxide, barium hydroxide, can be safely used to lower the acidity of the stomach. This is wrong because barium hydroxide is alkaline and it is soluble, so it will not lower the acidity of the so it will lower the acidity of the stomach, but it's soluble, not insoluble. So question 18, a solid X was placed in an excess of the liquid Y. A colorless gas was given off and a white precipitate was seen. The precipitate was not X. What could be the identities of X and Y? So barium carbonate and water. The carbonates of group 2 are not soluble, so this cannot be the correct answer because when barium carbonate dissolves in water, there's nothing is going to happen basically. It's just going to float around. Calcium and dilute H2SO4. Calcium sulfate is formed here, so the solubility of the sulfates decreases, and therefore there'll be a white precipitate. So this can be a feasible option because when the calcium, so the precipitate will not be X because X is calcium. The precipitate is calcium sulfate. Magnesium and dilute H2SO4. MgSO4 forms and it dissolves, so we don't see any precipitate, so this cannot be the answer. Strontium carbonate and dilute HCl. This will react to give strontium chloride, which is very soluble. All chlorides are soluble, so apart from silver chloride. So this will also not be the correct answer because we won't see any precipitate, and therefore B is the answer. Question 19. Two oxides of period 3 elements are added separately to water. Both react to form colorless solutions. One solution is alkaline, the other is acidic. Okay. What could be the two oxides? So aluminium oxide and silicon oxide. No, this cannot be the answer because aluminium oxide is insoluble in water. So both A and B won't be the correct answers because they say that both react to form colorless solutions, and therefore this is not the case in the case of Al2O3. Sodium oxide and P4O10. So sodium oxide will dissolve to give NaOH, which is alkaline, and P4O10 will dissolve to give phosphoric acid, I think. Yeah, and that will be acidic, and therefore this can be the correct answer. Sodium oxide and silicon dioxide will not dissolve, so this can't be the answer, and therefore option C is the answer. Question 20. Which compound shows stereoisomerism? So by stereoisomerism, we mean geometrical or optical isomerism. So it can be either, it can be both. We'll have to check. So 2-methyl-butene. In these types of questions, always draw out the skeletal or structural formula, and that will make your life easier. So 2-methyl-butene will be something like this compound, and this will not show stereoisomerism because we have two of the same groups connected to this carbon, and therefore there will be no geometrical isomerism, and there is no chiral center, so no optical isomerism. So this cannot be the answer. Then 2-chloropropane 1-ol. Again, let's draw it out. 2-chloropropane 1-ol will look something like this, and it will not show geometric isomerism because there is no alkene group here, but this carbon is a chiral center because it has 4 different groups attached, so it will show optical isomerism, and therefore this can be the correct answer. Then option C, difluorochlorobromomethane. Wow, that's a mouthful. So difluorochlorobromomethane will simply be CF2ClBr, and this does not have any double bonds, carbon-carbon double bonds, so no geometric isomerism, and this carbon is not a chiral center because it has 2 fluorines attached to it, so no optical isomerism, so this cannot be the answer. Pent1-ene, let's draw it out. 1, 2, 3, 4, 5. This is pent1-ene, and on the terminal carbon we have 2 hydrogens attached, so there cannot be any geometric isomerism, and there is no chiral center, so there is no optical isomerism. So option B is the answer. Question 21. 2 carbon-containing products result from the reaction of alkene Z with the hot concentrated acidified solution of potassium manganate. One product forms an orange precipitate with 2,4-dinitrophenylhydrazine reagent. The other product is a gas which gives a white precipitate with aqueous calcium hydroxide. So orange precipitate with 2,4-dinitrophenylhydrazine, underline this because this means that it is either a ketone or an aldehyde. So it's a carbonyl compound, and the other product is a gas which gives a white precipitate with aqueous calcium hydroxide. So this means that CO2 is produced, and so here we know carbonyl compound, here we know CO2 is produced, and we know that it has to be a ketone and not an aldehyde, because the aldehyde which is formed from this reaction will oxidize further, because potassium manganate is a very strong oxidizing agent. It will oxidize further to a carboxylic acid. So we know that it has to be a ketone. So the carbonyl compound is a ketone, because if a carboxylic acid is formed, through an aldehyde, there will be no orange precipitate with 2,4-DNPH. So which alkene could be alkene Z? So let's go through all the options. But2-ene. This is but2-ene, and this will only give one product, which is CH3CO2H, because because these two are the same. These two carbons are the same environment, and they are connected to one hydrogen and one methyl group. So they'll give an aldehyde, which will oxidize to give a carboxylic acid. So CH3CO2H, and therefore this cannot be the answer. 2-methylpropene, CH3 whole twice CH2. This is 2-methylpropene. So this carbon will give CO2 because it is attached to two methyl groups and no hydrogen atoms. And this carbon will give CO2. This first carbon will give a ketone, and the other carbon will give a CO2. And this is what we want from the conditions given in the question, and therefore this can be a feasible answer. 2-methylbutene, I'm drawing it out here on the far right, CH3 whole twice CH3. So this will give a ketone, but this will give a carboxylic acid because it has one H and one methyl group, so RCOOH. And we don't want a carboxylic acid, we want carbon dioxide, so this cannot be the answer. And then the last option is propene, which is CH3, CH2. This will give CO2, but this part will give a carboxylic acid, and therefore this is not the correct answer because we don't get any ketone. So B will be the correct answer. Question 22. What is the correct mechanism for the addition of hydrogen bromide to ethene? So this is electrophilic addition, and so we look at option A. This is wrong because if you see, electrophilic addition is attack from the double bond, not into the double bond. So that's the first problem. The second problem is that it says that hydrogen has the delta negative charge and bromine has the delta positive charge. And this is not true because bromine is more electronegative compared to hydrogen. Third thing is that this shows that this carbocation is attacking to the hydrogen, and that's not possible because attack always happens from the nucleophile into the electrophile, from the more electron rich into the electron poor environment. So it should be, the arrow should be like this. So all in all, this mechanism is wrong. Option B, the double bond attacks hydrogen, which has a delta positive charge, correct. And then the lone pair, this bond pair goes into the bromine, which has a delta negative charge. That's correct as well. Then the carbocation is attacked by the bromide, the electron rich species, and that's correct as well. So this mechanism works. Option C, again, bromine can't be delta positive, so we reject it right away. Option D, the hydrogen delta positive, it is delta positive, but it does not attack into the double bond. It should be the other way around. So this is wrong as well. So option B is the correct answer. Question 23. Halogenoalkanes react with nucleophiles such as hydroxide ions. Which pair of halogenoalkanes both react via an SN1 mechanism? So SN1 is when we have a tertiary carbocation, which basically the mechanism looks something like this. Let's say this is R, R1 and R2. So, and this is X, can be halogen, hydroxyl, we don't know. So this goes first, then we get a carbocation plus R1, R2. So we get a carbocation, and then the nucleophile, whatever the other nucleophile is, in this case it's hydroxide, attacks into the carbocation. So both should be tertiary in order for an SN1 to happen, because tertiary carbocations are more stable than primary carbocations, and therefore SN1 will only happen in tertiary and sometimes in secondary and not at all in primary. So option A, both tertiary, this works. Option B, this is primary, So definitely not. This is secondary, so we can't really say. So option B, all in all, cannot be correct. Option C, both primary, not correct. Option D, one tertiary, that works, but the second one is primary, so that does not work. So it has to be option A, the answer. Question 24. A mixture of ethanol and methanol is burned in oxygen to produce 35 centimeter cube of carbon dioxide and 55 centimeter cube of water. Complete combustion occurs and the volumes of both products are measured at 101 kilopascals and 120 degrees Celsius. What is the molar ratio ethanol to methanol in the mixture? So this question has a lot involved in this, and it is a bit of a cruel question to give given the time constraints that you have in the exam, but there'll always be one or two of these just because they like being cruel. So first we write out the balanced equation for the combustion of both methanol and ethanol to get somewhere. So we write them down here. CH3OH plus O2 gives 2CO2. I'll balance this here as well. So 2CO2 plus 4H2O. And the second balanced equation is C2H5OH plus 3O2 gives 2CO2 plus 3H2O. So this is balanced now, and one is the combustion of methanol, the other is the combustion of ethanol, and we have to find out the mixture of ethanol to methanol, right? So let's say that the number of moles of ethanol is Y and the number of moles of methanol is X, right? So we know that we can calculate the total number of moles in this reaction, and we can do that by first calculating the number of moles of carbon dioxide produced in total. So CO2 N is equal to 1. So we use the equation PV is equal to nRT, which is the ideal gas equation, and N is equal to PV over RT. Remember, temperature is in Kelvin, not in degrees Celsius. And yeah, so the N is equal to 101,000 times 35 into 10 to the power of minus 6 because we are using SI units in this equation always. So they've given the volumes in centimeter cube, we have to use them in meter cube. So that's where the 10 to the power minus 6 comes from. R is the universal gas constant, 8.314, and then temperature is 120 plus 273, which is the conversion from degrees Celsius to Kelvin. So this gives us 0.001081899 moles of carbon dioxide. So we know that the total number of moles of carbon dioxide is this. So when we look at the equation of methanol, we know that that 1 mole of methanol makes 1 mole of carbon dioxide. It's a 1:1 ratio. And we know that 1 mole of ethanol makes 2 moles of carbon dioxide. So we can write down an equation, a simultaneous equation, which is x plus 2y is equal to 0.00108, because x moles will give x moles of CO2, x moles of methanol will give x moles of CO2, and y moles of ethanol will give 2y moles of CO2. Now we use the same method to calculate the moles of H2O as well. So PV is equal to nRT again. Remember, H2O is in vapor form, gaseous form, that's why we use the ideal gas equation. And this gives us 0.001700128 moles. And if you look at the molar ratios again, 1 mole of methanol gives 2 moles of water, and 1 mole of ethanol gives 3 moles of water. So when we write the equation, it's 2x plus 3y equal to 0.00170. So we'll solve this system of equations and we get x equal to 0.000155 and y equals to 0.000464, and the ratio of x to y is 1:3. But they've asked ethanol to methanol and not the other way around, so it will be 3:1. Option D. And then 25, two reactions are shown. Only one product is identified in each reaction. Ethanol plus acidified dichromate ions gives ethanol, this is oxidation, and ethanol plus sodium gives sodium ethoxide. Which statement about these reactions is correct? The formations of both ethanol and sodium ethoxide are redox reactions. That is right for the first one because ethanol is being oxidized to ethanol and the dichromate ions are being reduced. And then the second one, we have molecular sodium here, but we have Na plus ions. So not molecular, I mean atomic sodium here, Na, and we have Na plus ions in sodium ethoxide, which means the sodium has been oxidized, and the ethanol, which means has been reduced. And it's not the ethanol that is reduced actually, it is the ethanol that is reduced, sorry, yeah. So ethanol is reduced, sodium is oxidized, so this statement is correct, but we'll read all the other ones. The formations of both ethanol and sodium ethoxide result in color changes. This is wrong because the first one you do see a color change. It's from orange to green, whereas in the second one you do not see a color change. Ethanol plus sodium you'll not see a color change, you'll only see hydrogen gas being evolved. And then option C, the formation of ethanol is catalyzed by potassium dichromate. The potassium dichromate is not a catalyst, it's an oxidizing agent. A catalyst does not get used up during the reaction, an oxidizing agent does. So it is not a catalyst. The formation of sodium ethoxide is a dehydration reaction. That is wrong because you're not removing any water. So it's not dehydration. So the answer is option A. Question 26. The skeletal formulae of three compounds are shown, R, S and T. Which compounds give positive test with 2,4-dinitrophenylhydrazine reagent? So this is only for carbonyl compounds. R is an aldehyde, so yes, it will give a positive test. S is a carboxylic acid, will not give a positive test. T is an ester, it will also not give a positive test. So the answer will be R only, which is A. Now, question 27. The diagram shows the structure of a compound formed by the reaction of HCN with the carbonyl compound X. What is the mechanism of this reaction and what is the functional group in X? So, you see the cyanide ions, you see the cyanide group, the hydroxyl group, and you see HCN with the carbonyl compound. Immediately, it should come to your mind, it's a nucleophilic addition reaction. So, C and D, one of them will be the answer. And functional group in X, it should be a ketone because we have two R groups. So the carbonyl compound initially must have been C4H9, COH3C. This is a ketone because it has two R groups. So D is the answer. Question 28. Compound Y is treated with a single reagent under suitable conditions. 2-methyl-butanoic acid is produced. What could compound Y be? Okay, so we need to produce 2-methyl-butanoic acid. Let's see what all we have. 2-methyl-butanoic. So let's draw the 2-methyl-butanoic acid because let's see what our product is. So CH3, CH2, CH, CH3, CO2H. So 1, 2, 3, 4, 5 carbons in the main chain, and then we have another carbon here, which is the methyl group. So 2-methyl. I'm a bit wrong here. It should be CH, CH3, CO2H. So we have 4 carbons in the main chain. That's why the butanoic acid, and we have a methyl group on the second carbon atom. And you can, because it's second because you number it this way, not the way I've done, 1, 2, 3, 4, because this is the main functional group, the carboxylic acid. So yeah, on the second carbon, there's a methyl group. What could compound Y be? Pentane 2-on? Nah, because obviously it's a ketone. You can't get to a carboxylic acid with a ketone. So definitely not possible. 2-methyl-butan-2-ol, let's draw it out. So CH3, CH2, COH, CH3 whole twice. So this is 2-methyl butane 2-ol, and this is a secondary alcohol, as you can see, because this carbon atom is bound to this is not a secondary alcohol, it's a tertiary alcohol, my mistake. So it's a tertiary alcohol because this carbon atom is bound to 2 others and 3 others, and that's why this cannot be oxidized to form anything, so it cannot be used to form a carboxylic acid. So this is wrong as well. And then option C, 2-methyl butane nitrile, CH3 CH2 CH CH3 Cn. So 1 2 3 4, that's why butane nitrile. And the second carbon atom, 1 2 3 4, second carbon atom has a methyl group on it. So this can be used to make the carboxylic acid, because the this CN group can be hydrolyzed to the carboxylic acid group, and it will eventually give you 2-methyl butanoic acid. So this sounds correct. The last one, methyl propane nitrile, is CH3 whole twice CHCN. This will give you CH3 whole twice CO2H upon not CO2H, sorry, CHCO2H upon hydrolysis, and that's not the same as this product. So option D cannot be correct. Option C is the answer. 2 reactions are shown. CH3CH CO2H in the presence of LiAlH4 gives alcohol P. Let's stop right there and see what's happening. A lithium aluminium hydride is a reducing agent. It will reduce the carboxylic acid into the alcohol, the primary alcohol, because remember, only primary alcohols oxidize to give carboxylic acids and aldehydes. So we get CH3 whole twice CH CH2OH. That is alcohol P. The CO2H group is converted to CH2OH upon reduction. Then the second reaction is CH3 CO2 CH3 whole twice, and it's hydrolyzed into alcohol Q and acid R. So this group should remind you of an ester, and esters hydrolyzed into carboxylic acids and alcohols. So the carboxylic acid will be CH3CO2H, and the alcohol will be CH3 whole twice CHOH. So this is the alcohol that is produced. This is a secondary alcohol because this carbon atom is bound to 2 other carbon atoms. So to which classes of alcohols do P and Q belong? So P we have seen is primary and Q we have seen is secondary, and therefore the option B should be the answer. Question 30. The infrared spectrum of molecule Z is shown, and what could be the identity of Z? So before looking at the molecules that are given in the options, let's decipher this spectrum. So around 1300 we have a sharp peak which is CO single bond. Then we have a weak peak around 1700 which is carbon-carbon double bonds, and then we have some weak peaks over here, and these correspond to CH stretches. So we are looking for a compound which has a carbon-carbon double bond, CH bonds, and this is not very important because it's probably all of the options will have CH single bonds. So, and then CO single bond, that's what we are looking for. So the option A, it has carbon-carbon double bonds, it has carbon-oxygen single bonds, but it also has carbon-oxygen double bond, which is not in the spectrum, so this cannot be the answer. Option B also has, option A has an alcohol group, which is not there in the spectrum. It should be something like this over here, and it's not there, so that's why option A cannot be correct. Option B, carboxylic acid, again alcohol groups, not possible. And option C, again carbon-carbon double bond, not possible. Carbon-oxygen double bond, not possible. Option D, it has carbon-carbon double bonds, it has carbon-oxygen single bonds, and it does not have any alcohol group. So option D is the correct answer. Now we move on to question 31, and I'm not sure if the format is still the same for these for this section, but anyways, we'll go through it. So question 31, which statements about first ionization energies are correct? They are always endothermic. That's correct, because we need to give energy to remove electrons. They decrease down group 2. That's correct as well, because even though the nuclear charge increases, the radius and shielding also increase, and they outweigh the increased nuclear charge. And then they decrease across period 3. That's wrong, because as we go across period 3, nuclear charge increases, atomic radius decreases, and shielding remains relatively constant. So the correct answer is B, which is for 1 and 2. Question 32. The equation shows the decomposition of 3 moles of an ion containing chromium in an acid solution. Okay, so they have given us this equation. Which statements are correct? 1 mole of the chromium containing compound is reduced, right? So let's see what's happening. We have let's calculate the oxidation number. So this is 4 oxygens, which should give minus 2 times 4 is equal to minus 8. The overall charge is minus 3, which means the chromium should be plus 5. So we have Cr plus 5 on this side. We have 1 Cr3 plus here, and in this compound we have minus 2 times 4 again, which is minus 8, and we have an overall charge of minus 2, which means that this should be a plus 6. So we know that 2 moles of chromium have been oxidized from plus 5 to plus 6, and 1 mole of chromium has been reduced from plus 5 to plus 3. So 1 mole of chromium is reduced, correct. 2 moles of chromium is oxidized, correct. 3 moles of electrons are transferred. That is wrong, because we have 2 moles from the oxidation and 2 from the reduction. So therefore the correct answer is B. Question 33. Disaccharides are hydrolyzed in slightly acidic solutions. This reaction is very slow. A biological catalyst is added to a slightly acidic mixture of 3 disaccharides, sucrose, maltose, and lactose. The hydrolysis reaction remains slow for sucrose and maltose, but is now much faster for lactose. Which statements about the catalyst are correct? The catalyst increases the activation energy of all 3 hydrolysis reactions. First of all, a catalyst does not increase the activation energy, it decreases the activation energy. So this has to be wrong. And second of all, it only decreases the activation energy for the lactose reaction, not for the sucrose and maltose reactions. And the catalyst shows specificity. That's correct, because it only does catalysis for lactose. And the hydrolysis of lactose using a catalyst has a different mechanism to the hydrolysis of lactose without a catalyst. Yes, because remember, a catalyst takes the reaction through an alternate pathway with lower activation energy, so the mechanism has to be different. And therefore the correct answer is C. Question 34. Element X is a solid under room conditions. It occurs as a contaminant of fossil fuels. Its oxide Y is formed when fossil fuels are burned. In the atmosphere, Y can be further oxidized to Z. Which statements about X, Y, and Z are correct? So before we go to these statements, let's look at what X, Y, and Z might be. So X is a solid under room conditions. Okay, that doesn't help. It occurs as a contaminant of fossil fuels. Now, if you remember from your syllabus, one of the main contaminants of fossil fuels is sulfur, and that's why we have to carry out desulfurization of fuel. And sulfur is also solid under room conditions, so it satisfies both these conditions. So let's assume element X is sulfur for the time being. Its oxide Y is formed when fossil fuels are burned. Sulfur dioxide, that's correct. Sulfur dioxide is formed when fossil fuels are burned. In the atmosphere, Y can be further oxidized to Z. This further oxidation does happen for SO2, it forms SO3. So this is an educated guess that we have used here. So which statements about X, Y, and Z are correct? Atoms of X have paired p electrons. So sulfur will have the same electronic configuration of as oxygen. So it will have 1s. Let's write the electronic configuration for oxygen: 1s2, 2s2, and 2p4. Right. So if you look at the p electrons for this atom for X, so we look at the p electrons 1, 2, 3, and 4. So we have a pair of p electrons. So this statement is correct. And then option 2, the atmospheric oxidation of Y to Z is a catalyzed reaction. Yes, nitrous oxide is used for the catalysis. Option 3, with water, Z forms a strong acid. Yes, it forms H2SO4, which is such a strong acid that it will melt your bones. Seriously. So this is correct as well, and that's A. Question 35, which reagents produce a solution of sodium chlorate? 5. So what is sodium chlorate and what does this 5 mean? It means that it's NaClO3 because the 5 means that the chlorine is in a +5 oxidation state. So this is produced, if you recall, from the reaction of chlorine with hot concentrated sodium hydroxide solution, which is option 1 basically, and that is definitely used. And chlorine and cold dilute sodium hydroxide, no, this is wrong because it forms NaClO instead of NaClO3. And chlorine dissolved at water in room temperature, again it gives chlorate ions, not ClO3 negative ions. So we know that the only option that's correct is 1, and that's D. Question 36. Which statements help to explain the increase in melting point from sodium to aluminium? So the charge on the metal ion increases. Yes, that's correct, because as the charge increases, the metallic bonding between the metal ions and the sea of free electrons becomes stronger, so it becomes harder to melt the metal. And then there are more delocalized electrons per metal ion. Yes, because as we go from sodium to aluminium, we go from Na plus to Mg2 plus to Al3 plus. So for each metal ion, the number of free electrons increases from 1 to 3. So this is correct. And then third option, the radius of the metal ion decreases. Yes, because as the charge increases, the outer electrons are pulled closer to the nucleus, and therefore the radius of the metal decreases. So all 3 options are correct, and that's A. And next up is, I think I've missed a question, or have I not? Yeah, sorry, I haven't missed anything. And question 37. The diagram shows a molecule of a compound used as a flame retardant. Actually, going back to question 36, I just realized that this should not be A, because even though all these options are correct, we jumped from the question, which is what I was trying to explain to you right in the beginning of the paper. That read the question carefully. It says explain the increase in melting point from sodium to aluminium, and it does not talk about the characteristics of the metal. And as far as these options go, only the first one explains the increase in the melting point of from sodium to aluminium, because the metallic bonds will only be stronger when the force of attraction between the metal ion and the sea of electrons becomes stronger. The number of delocalized electrons and the radius of the metal ion, they don't matter. They occur as a consequence of the increase of the charge on the metal ion, but they don't explain the increase in melting point. So I'm sorry for that mistake, but it should be correct. The answer should be D. Even though option 2 and 3 are factually correct, they don't help explain the increase in melting point. Now question 37. The diagram shows a molecule of a compound used as a flame retardant. Okay. So which statements about the structure are correct? Each brominated carbon atom is chiral. And that's correct because each of these carbon atoms are bound to 4 different groups. The molecular formula is C12H20Br6. Let's calculate. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 carbons. So far so good. Hydrogens, we have 1 here, so that's 2, 3 and 4, 5 and 6, 7, 8, 9 and 10, 11 and 12, 13, 14, 15 and 16, 17 and 18. We have 18 hydrogens. So this molecular formula is not correct because even though we have 6 bromines, 12 carbons, we have 18 hydrogens and not 20 hydrogens. So this is not correct. And then the C-C-C bond angles are all 120 degrees. That is wrong because there are no carbon-carbon double bonds. All the carbon atoms are tetrahedral, sp3, and therefore the bond angles are all 109.5 degrees. So the answer is D. And the third last question, bromoethane reacts with sodium hydroxide in different ways depending on the solvent used. Which rows about these reactions are correct? Option 1, solvent used water, organic product ethane 1,2-diol. No, this is wrong because we have a single bromine atom. So bromoethane is CH3CH2Br. So we'll only get a single substitution. Remember, water is when nucleophilic substitution occurs, and this will give CH3CH2OH, not HOCH2CH2OH. So it will only give us ethanol and not ethane 1,2-diol. And option 2, solvent used ethanol, organic product ethene. That is correct because when we use NaOH in ethanol, it's an elimination reaction. So ethene will be the answer. And then last one, water, ethanol, as we discussed in option 1, this is correct. So C will be the answer. Question 39. 3 compounds X, Y and Z are shown. X is C2H5COCH3, a ketone. Y is C2H5CHO, aldehyde. Z is CH3CO2H, carboxylic acid. So which statements about X, Y and Z are correct? X reacts with alkaline aqueous iodine. Remember, the conditions for this are either CH3CO or CH3CHOH. So only these 2 types of compounds will react with alkaline aqueous iodine, and therefore X does have this CH3CO, so this is correct. Y reacts with Tollen's reagent. This is correct because it's an aldehyde and it reacts with Tollen's reagent. Z does not react with alkaline aqueous iodine. This is also correct because even though we have CH3CO, it's an acid, and remember the acid will react with the alkali because alkaline aqueous iodine. So you will not get it will react, but it will not react with the iodine. It will only react with the alkali in the alkaline aqueous iodine. So this is wrong. So this is correct in the sense that it will not react, and therefore the answer is A. Question 40. 5-hydroxypentanoic acid is readily converted into the cyclic compound L. And which statements about this reaction are correct? Acidified sodium dichromate is used as a reagent. So 5-hydroxypentanoic acid, let's draw this out. So we have HO2C. Let's start counting from here. CH2, 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 CH2OH. So that's 5-hydroxypentanoic acid because 5 carbon atoms, alcohol at the 5th position, so hydroxy and then carboxylic acid. Acidified sodium dichromate is used as a reagent. No, this is not a reagent. This is this is an oxidizing agent. This is an esterification reaction, remember. So in this esterification reaction, the molecule reacts within itself to produce a cyclic ester. But for those conditions, we use concentrated H2SO4 and heat for this reaction. We do not use sodium dichromate. And option 2, a water molecule is produced in the reaction. That is correct, because remember, it's a condensation reaction. The carboxylic acid reacts with the alcohol and the water is kicked out. And the reaction can be catalyzed by concentrated H2SO4. This is also correct. So C is the correct answer. So that was May-June 2021, paper 13. I'm sorry I made some mistakes during this paper, but I hope the answers make sense. And if you have any problems, leave them in the comment section. Thank you.